Hello everybody, getting ready to do lesson 3.4 part 3 today of calculus math, pre-calculus math classwork. And for classwork we have 54 points here for classwork, and solving exponential and logarithmic function, or rather equations, logarithmic equations. We got 62 points here of classwork, so note-taking guide would really come in handy here. And we only have 2 points here for your notebook, so take note. And today's Bellwork teachers sketch the graph of these functions with these limitations here on the function. Give your students about 5 minutes to do that. Okay, welcome back for the solutions to today's Bellwork. Students, what you should have for the first one would be this situation here, negative x squared plus 4. You have a y-intercept of 4, and then you have a negative slope here, 1/2 of a parabola, and then 2x here is a line, and x is going to be less than 0, so you have a termination here at the origin, but you have a line like that. And then for the second one here, you have a parabola that points upwards here. X is greater than -1, so your parabola starts here at -1 and it goes up like that, plus 1, so it has y-intercept here at 1, and then x minus 9, x is less than or equal to -1. It starts here, so it has a slope, a positive slope of 1, but it goes like that, and it has a it would have a y-intercept here at -9. Okay, today's lesson, classwork, page 1, to change the base formula, prove the change of base formula. So log base ax equals log base bx over log base ba. So begin by letting y equal log base ax, so we're going to let y equal this, and then writing the equivalent exponential form, a to the y equals x. So a to the y would equal x by writing that in an exponential form. Now taking the logarithms with base b of each side produces the following. So log base b a to the y equals log base b to the x. After we do that, log base b, then we bring our y down. Y times log base b a equals log base b to the x power property. And then to solve for y, we divide through by log base b a. Then we get log base bx over log base ba. Divide each side by log base ba. So log base ax equals log base bx over log base ba. Replace y with log base ax. So let's try another one here. Prove the change of base formula for the indicated base. So this one here, log base ax equals log base ex over log base ea. So y equals log base ax, so we make y equal to that. And then a to the y equals x in this case here. So log base ay, log base b, log base e a to the y equals log base e to the x. Then we bring this down here, y times log base e to the a equals log base e to the x. And then we divide through by log base e a, and we get y equals log base e to x equals log base e a. And then we plug back in our value back in here, log base a x equals log base e to the log base e x equals log base e a, which you could go with natural log x over natural log a. And then down here, same thing, y equals log base a. Then we're going to make y equal that. Then we have log base 10 x over log base 10a. Then a to the y would equal x. In this case here, a to the y would equal x. So log base 10 a to the y equals log base 10 x. Then we bring down our y log base 10a equals log base 10x. Then we divide through, then we end up with this. Then we plug back in our value for y, log base a to the x equals log base 10x over log base 10a. So that would prove it there. Excuse me. Okay, so then to our first page slide here for your notebook on this lesson. Equations that involve combinations of algebraic functions, exponential functions, and or logarithmic functions can be very difficult to solve by algebraic procedures. Here again you can take advantage of graphing utility. So, approximating the solution of an equation. Approximate to 3 decimal places the solution of natural log x equals x squared minus 2. First, we write the equation like so. Natural log x minus x squared plus 2. We bring in our x squared and 2 over, and then make it equal to 0. Then use the graphing utility to graph it. So here is the graph of this here. We have an x-intercept here and an x-intercept there. Which one is it? Well, from this graph you can see the equation has 2 solutions. Using the 0 root feature you can approximate 2 solutions. So x equals 0.138 and out here 1.564. So to find out which one we have to check it. Equation and then plug in here. Substitute 0.138 for x. And then we get negative 1.9805 approximately equals negative 1.981 So that checks. The first one checks. So now we're going to substitute in this intersect here up here. Substitute 1.564, and that one checks to 0.4461, 0.4472. That's close enough for it to check. So the 2 solutions seem reasonable in that situation. So let's try it here on this one here. Log base 10x equals x cubed minus 3. So if we graph y equals log base 10x minus x cubed plus 3. So meaning we bring these 2 over here and then make this equal to 0. You obtain 2 zeros here. So if you look at your graph, you'll find a 0 there and a 0 there, providing you can get your viewing screen, your viewing window adjusted to see that. And then down here, same thing. We bring this over here, log base 10x squared minus 4. And then we make this equal to 0. You obtain 2 zeros at x equals plus or minus 100 there. Okay, so now doubling an investment. Deposit 500 in an account, pay 6.75 interest, compounded continuously. How long will it take your money to double? So using the formula for continuous compounding, you can find that the balance in the account is, here's your formula, A equals PE to the RT. So 500E to the R is our rate times T. And to find the time required for balance to double, let A equals 1,000. Because we're doubling 500, so we're going to let A equal 1,000. And then solve the resulting equation for T. So when we make this equal 1,000, here's your setup. And then we'll get down to this, we'll get this far, divide each side by 500, and then we take the natural log of both sides, and then we come up with this here, 0.0675t equals natural log 2, then we crank that out. When we crank that out, t equals natural log 2 over 0.0675, divide each side by that amount there. Then t equals 10.27 using a calculator. And then that would be the graph here of it here. So you could also graph that function. The balancing account will double after 10.27 years. And you can find that here on your graph as well. Okay, so we try a problem here. Same kind of problem here. $1,000 investment, doubling time. and then compounded continued tripling time as well. So doubling $1,000 at this rate here, you get 9.24 years by using the same method. And then tripling time would be 14.65 years for $1,000 at 7. Okay, average salary for a public school teachers, 85 through 2007. The average salary in thousands of dollars for public school teachers for year T can be modeled by the equation here. Here's your model for that. 5 less than T, T is less than 27. Where T equals 5 represents 85, during which the year the average salary for public school teachers, during which year did the average salary for public school teachers reach $45,000? So we're going to write our original equation. So we're going to make this equal 45, since y is our dollar amount. And we're going to move this over here, and we end up with 15.206. Natural log t equals 47.983. So we added that to both sides. Now, divide each side by 15.206. We have natural log t equal this amount. And then we exponentiate both sides, e. So exponentiate each side. These will cancel here. So we have t equals this amount, 47.93 over 15.206. And then when we crank that out, we get 23.47. So it'd be 23.47 years when, because t equals 5 represents 85, follows that the average salary for public school teachers reached $45,000 in 2003. So let's try a problem here. Banks, 99 through 2009 can be modeled by this. Numbers of Y of commercial banks, where T represents the year with T equals 9 corresponding to 1999, and what year were there 7,100 commercial banks. So to determine that, we make this function here equal 7,100, and then we crank that out to find T. Naturally, we end up 6,007 over 20, 77.6. Then we exponentiate both sides, and when we crank this out here, we get 18.0 equals T, or 2008 would be 7,100 commercial banks. And that is your lesson today from Pre-Calculus Math. Email me here for lesson sheets, homework sheets, note-taking guides, class worksheets, whatever. Thank you.